So I've just got done with my cold start video on my 200 horsepower Johnson there. So if you want to check that video out, it's in the video description below. But what I'm going to show you in this video is diagnosing a check engine alarm on the System Check equipped Johnson Evinrudes. I've been fishing some tournaments here recently. I live in North Alabama, so I'm close to Guntersville, Wheeler Wilson, Pickwick, all of those great systems. Well, it started off above 5,000 RPMs, and then it's starting to get much more frequent where I need to really take a day off, which is what I am, and dive into what's causing this problem. But my check engine alarm and horn sounds on the motor whenever I'm running at higher RPMs. What's interesting too, this is really peculiar, I haven't found any forums that mention this specific phenomena, but say there's no wind, the water's flat, and you're running wide open throttle. I can go all the way up to 52, 5,300 RPMs. I'm fine, screaming down the river. But if I hit a bump, if I hit another boat traffic wave, even a little bit, just that slight jar will trigger the alarm. So I'm not sure what causes that alarm. So I'm gonna show you how to fix that alarm in this video, hopefully. So the first step is to diagnose is it on the boat side or is it on the motor side. And to do that, you take just a 6-gallon test tank and you disconnect the fuel line at the hand pump and hook it up to the tank and run it down the river. So that's what we're gonna do. And I'm gonna show you how I'm doing that. Hey, this is Future Justin. I realized that I didn't explain why a check engine light or alarm was, quote, bad or could cause engine trouble. Check engine light is caused or indicates on the motor that I have a fuel restriction, which means at the higher RPMs you need more fuel, so the engine pulls or tries to pull more fuel, but it can't. And the alarm is tripped by a pressure sensor that is looking for a drop or pressure below a certain threshold. If that pressure drops, then it's saying, hey, there's a fuel restriction. I'm not getting the fuel required. Something's wrong. Check it out. Okay. So how does that cause motor damage? Well, you're still sucking in air at the required rate. So what that causes is if you're sucking in the same amount of air, but the fuel drops, then you now have a lean condition, which means your motor's gonna run hotter, especially in a 2-cycle, it's gonna run hotter. Because you're burning, you're running hotter. And that's where the damage can come from, is basically a lean condition, overheats, melt a piston, crack some rings, etc. So that's why it's really important to get this figured out. But I just want to drop a note and say that. Let's go back to past Justin. So basically, here I have my test tank. Typically these come with Johnson Evinrude, fuel couple fittings. I removed that. This is a 1/4 MPT to a 3/8 inch barb. It does not have the anti-siphon valve in it, so this is just a straight fitting. And I'm going to need to get some hose clamps, but I'm going to take a hose clamp here and a hose clamp here, and I'm going to undo that hand primer bulb, stick it into here, fill this up with gas, and we're going to go run it down the river and see if the alarm still occurs. If the alarm still occurs, then it is isolated to this system, including this tank setup. So that's why I didn't use a fitting or the Johnson Evinrude fuel connectors, because I want this to be not restrict the flow at all. Alright, so you can see we got the test tank hooked up, filled it up with non-ethanol gas, sitting there idling, warming up. We're gonna go make a few runs, and hopefully the check engine alarm does not come on. If it does, that means we've isolated the problem from pretty much the hand pump down there to the motor. Turn it off, let it cool down a little bit. We'll go at it again. Probably make about 2 or 3 runs doing this. So it's been several months since I've gotten the motor up to that level of RPMs without having to back off, because I get a check engine light. Usually whenever it happens, I just back off. So running the test tank, I got her up to about 5,500 RPMs, about 62 miles an hour, and hit a few waves or bumps, if you will, and the alarm didn't sound like it has been doing before. So what that makes me think is it's either the anti-siphon valve, or it could be that fuel pickup in the tank, because, and that makes more sense with the bump and the sloshing around of the gas. If there's a crack in some line in that fitting, it could lose pressure, and thereby, you know, triggering that alarm. So we're gonna go back. I'm gonna remove the anti-siphon valve, and I'm gonna put just a straight barbed fitting. Maybe that's it. If that fixes it, great. But if not, then I'm gonna have to get into the tank. All right, so we're back at my house. I'm gonna take the seats off and remove these panels here so we can get to the gas tank and replace the anti-siphon valve. I'm going to replace it with just a straight fitting. You can see that there is no check valve in there that prevents siphoning. So hopefully all the resistance to siphoning will be captured at the hand bulb. That'll stop all the fuel from draining back from the motor. I have to take my seats off first. I'm not really familiar with the OEM seats, but this is how I have to do it. Next, I got to remove this cap. Once this cap's moved, there's a row of screws here and a row of screws here on my boat, and that's all I got to take off. With those screws removed, I should be able just to lift this up. Alright, so I have the single line, or the single fuel tank here. There's the information, 46 gallon capacity, model F04603. So that's the tank I have. I don't have the double tank, but here is your anti-siphon valve. So we're going to replace it. With this valve. First thing you need to do is remove the line. This is new fuel line that I put on, I don't know, a couple of months ago. So I really doubt that this fuel line is the issue. It's really hard to remove because there's back pressure. You may have to take a screwdriver and carefully break the seal. The line is free on the other end at the hand pump, so it shouldn't be this hard. I think I'm just gonna remove it. This is probably the safe way. Shouldn't have to twist too many turns. Check valve looks to be working fine. Looks to be working. Releases the fuel and stops it. But maybe it's got something in it. Provides too much resistance for the fuel required to run this big motor. Make sure this is super clean. Make sure any thread sealer's away from the tip. And screw it in there. Slide that back on. Tighten her down. Alright, so we've hooked everything back up and we made sure that the hand pump works and gets firm. So that's good. Let's put the muffs back on it and make sure it idles well. Well, we can't do that because my muff's broke. Alright, so I'm on my way back to the river. I have removed the anti-siphon valve from the tank. I have reconnected the boat tank up to the motor. I'm not running a test tank. So hopefully what we discover is that anti-siphon valve was the issue. I messed around with it for a little bit. I couldn't feel it sticking or acting oddly in any way. So this should be interesting. If I get the check engine alarm this time, it's either the fuel pickup in my tank, or I bought AC Delco fuel line off Amazon, 3/8 inch ID. Maybe the wall strength of the fuel line isn't sufficient for the flow, and it's collapsing and causing a restriction that way at high RPMs. I don't know. Anyway, should be interesting. Oh, and PSA, always wear your seatbelt. All right, so we're back on the water here on Wheeler Lake. I did change the spark plugs while I was back at the house. Been meaning to do that for a while, so I figured I'd go ahead and do that. So I did change another variable, which is kind of a no-no, but I did it. But back on the water, we're hooked back up to the boat tank, and I've removed the anti-siphon valve from the 90-degree connector at the tank that goes to the fuel line to the motor. So we're gonna run it, and hopefully we don't get an alarm. If we don't get an alarm, then that means we probably fixed the problem, which is the anti-siphon valve. If we do get an alarm, then it's either the fuel pickup in the tank or the fuel line itself. So I don't know. Let's just hope it's the anti-siphon valve. Interesting. I don't know what that is, but when I hit bumps or the water's choppy, that's when it does its thing. I don't understand it. If anybody's experienced this, hit me up in the comments. All right, sorry about the lighting, it's nighttime, but with the anti-siphon valve removed and I'm still getting the check engine light, either my line's collapsing, which I don't think is the case since it's brand new 3/8 ID fuel line. So I think it's in this pickup assembly. It's also could be the reason why whenever I hit a bump and fuel sloshes around, if there's a crack in the hose at the top where there's air, it could you know grow that crack and cause it to lose pressure. So I'm going to remove this fitting and measure the threads so I can see if I can find one off Amazon. 0.665. This looks to be a 3/8 NPT National Pipe Thread. It's also a 3/8 NPT. It's 18 threads per inch, so the pitch is 18 threads per inch. Alright, so I got the new pickup line in the mail, and we're going to install it and reconnect the fuel line. I'm going to put back on the anti-siphon valve. I don't think that's the issue, but we're going to hook all this back up, put the seat back on, and then take her back out, and hopefully we don't get the alarm. Alright, so we got everything hooked back up. I put the anti-siphon valve back on. It was not sticking. The ball was moving freely. I don't think that was the issue, seeing as I got the alarm with the straight no check valve fitting as well. So I don't think this is the issue. This is only, I don't know, 3 or 4 months old. So I'm gonna put it back on. I want the anti-siphon valve on just because I think it's better for the system if the spring isn't bad. So we got the new fuel pickup tube installed. I reinstalled the anti-siphon valve, as I mentioned. I don't think that's the issue. And we're headed back out to Wheeler, and we're gonna check it out for the third time. And hopefully this time we don't get an alarm. But I'll let you know. You'll be along for the ride. That was about 4,000 RPM. Well, that didn't go as expected. I don't really know. I'm starting to think maybe it's the sensor. Maybe it's the sensor, I don't know. I mentioned earlier that I've replaced the fuel line twice. The reason I replaced it a second time is I bought this AC Delco fuel line off Amazon. It's somewhat compliant whenever you squeeze it in its diameter direction. I bought this line at a local Ace hardware store, fuel line. They both are fuel rated lines, and this one, it looks as to be a little more stiff. So what I was thinking in replacing to a more stiff line was, if I had a really compliant line on a really hot day, it's going to be pretty spongy, and I may get some sort of collapse in the line that would trigger a false alarm through the sensor. I replaced the line to the harder line, and I actually got the check engine alarm at lower RPMs and lower speeds. So I can't say for certain what that means, but it's my gut feel that the pressure sensor is just, or the sensor is just going bad over time. Hopefully replacing this is fairly simple. It is located right underneath your VRO pump, on the VRO pump bracket. So hopefully it's just removing some fuel lines and oil lines to get access to this, and then simply removing it and reinstalling it, and good to go. Hopefully I don't have to mess much with the VRO pump. I hope that is not the case, but stay tuned and we'll work through it step by step. Okay, this is the port side of the motor, and here is the VRO pump. The sensor is right here. You can see there the part number 437808, kind of covered in oil. Hopefully all we have to do is remove these fuel lines here, fuel and oil lines here, remove this cover, kind of push back the wires, and do a quick swap. First thing I'm going to do is remove this cover, because I can already tell that I'm going to need that space clamp. Make sure to be really careful when you're removing these screws. I have dropped them down into the lower cowling, and it's pain to retrieve them. Okay, the next thing I'm going to start removing these hoses. Now, it's always whenever you have a situation like this where you got a bunch of hoses, that you remember what hose goes where. If the hoses are a bunch of different diameters, then it's fairly straightforward, but just make note, take a picture with your phone so that you can look back on it later if you get confused, etc. It may be somewhat hard to see, but if you follow the screwdriver tip, there is a small hex head back here that holds this bracket, this metal bracket that pushes the sensor into this main VRO bracket. So we have to remove this hex head screw to remove the bracket that is clamping the sensor to the main bracket. So from what it appears, there is one hex head screw that if you look at this connector and this connector, you got to slide it right back in between these two corners to get to that. The frustrating thing is there looks to be like a little bracket that's in the way of the head back there. Again, it might be hard to see, but you might have to get a little creative on how you remove that without removing this whole assembly here. So I finally got it. It just takes a little bit of patience. That tab back there, that it may not be an interference for you, but for me it was. You just kind of have to take a screwdriver. You have to take a screwdriver and gently slide it in there, kind of twist to pry it back, and then slide your long, extended socket and extension over it quickly. Just be patient and you'll get it. It ended up being a metric number 8 size head. I have a feeling getting it out will be a lot easier than getting it back in. So once it's free, I would tilt up your socket, and this is probably why it's paramount to have a deep well socket so it can slide in there like that. So you can slide it in. Once you get it out, you can get it out that way. But be careful and don't lose the screw. Now the sensor, well, the bracket should come out first, right? And then the sensor. Keep in mind the sensor's still tied in to its fuel line connection. Here you can see where it's still connected. So gently take your pliers, slide that back, and pull out your electrical connection right here. Everything's kind of up in your face, I realize. This connector, it's just basically a tab system here. Pull it up over with your finger on one side. Actually just pull this connector here, just pull the two tabs on either side at the same time with your fingers, slide it out. The bracket comes over that. Next thing we do is gently get the fuel line off the switch. If it's been on there a while, may be somewhat difficult, so try twisting the sensor to kind of breaking the stiction and pulling while twisting. And there it comes. Before reassembly here, make sure that you put the bracket on first. See how it slides over, and then put the connector on. And it is keyed Next, we want to reconnect our line to the T, the fuel pump T. Make sure that's on there good. Snug. And now for the fun part. So make sure you pay attention to the orientation of that bracket, because I got it wrong. So it needs to go in an orientation like that. Alright, so here's where I'm getting a little creative. Got a paper towel and I wadded it up, and I've pushed it in there so I can get a little resistance, right, so it doesn't just slide in there, but I can keep it safe. And now what I have to do is I have to get this thing started without dropping it down, right, which may prove to be tricky. So I moved some connectors out of the way so you can see what I'm talking about here now, with that bracket, that plastic bracket back there being in the way of that bolt head. So yeah, remove some of these connectors and you can see it and get access to it a lot easier. Don't over torque it. Just get it good and tight. I'll just hook everything back up the way you had it. So before I put this plate back on, I'm going to go up front. And we're going to verify that nothing funny happens whenever we just turn the key on. So that's a good sign. If there was something wrong, the check engine light would have, once they all turned off, it would have popped back on. So at least there's nothing initially wrong with what we've done. As you can see, it's raining outside, so I can't test it out at the moment, but when I can, I'm gonna crank it up on some water muffs and check it out. Something pretty interesting is you can see here on the old sensor, there's a lot of cracks where the wires go in at the potting compound. A lot of cracks. So I don't know, maybe that's a good sign that it was going bad. Maybe that's why the alarm came off whenever I hit choppy water, is this connector was bouncing up and down, and it didn't have the strain relief it needed anymore, and causing an intermittent failure. Anyways, something of note. All right, so it's a couple of days later. I took off early from work. I'm gonna go check out the fix that I did and make sure that my engine's still running good. So you can see it's running. No check engine light, and let's see how she does. What would happen before is, I think because the sensor was bad, maybe as a diaphragm it would knock around, but if I ever hit a little chop, man, it would throw that alarm. It's not doing it, which is a good sign. So I ran from, you can see off in the distance, the Decatur Bridge. That's the 65 bridge. So I've probably run a couple of miles and no alarm. This is easily long enough for it to throw an alarm. We're gonna crank it up. Goes through its checks, cranks right up, and I head on back.